So this is the Elixir and Kafka talk. So if you are looking for something else, you know, it might be the wrong room. I think they announced it upstairs. That it was upstairs. So yeah, up in Grand. So yeah, this is for Kafka. Yeah, there's another talk about vehicle data streaming, um, but this is at Toyota we don't do that. You know, I'm not bitter. So I guess we'll get started. My name is Matthew Gardner. I am a software engineer at Toyota Connected, and oh wow, animations. So about me, I got my obligatory cat photo. I hope you enjoy it. You can find me on GitHub, and you can ping me on Elixir Slack. I've been doing Elixir stuff for a little over year and a half, and it's been awesome. I really enjoy it. I have a background of doing a bunch of different web stuff and mobile and things, and I think I'm most comfortable here. So I really enjoy it, and I hope you guys enjoy the journey that I'm going to share with you with Elixir and Kafka. So at Toyota Connected, we're the global data innovation company for Toyota. What that means is that we're building a platform for vehicle data to come through. We do something with that. Now that we have vehicle data coming through, you can do a lot of interesting things. So we have the whole IoT stuff for our cars, and we have a ton of data to deal with, and that's what we do. And so what we want to do is make the Toyota mobility programs better. How can we make the experience for the driver better? And some of the things we've been building is car sharing, ride sharing stuff. So when you have that data, you can make interesting apps and like fleet management. And if you have a lot of cars, you want to manage the fleet, you can use one of our stuff for that. That's what we're building today. So Kafka, what is it? How many here have used Kafka? Wow. All right. That's a lot of people. Okay, cool. What about other stuff like RabbitMQ? All right, a lot of people. All right, well then I probably don't have to tell you what it is. Well, basically, I'm going to do it anyway because it's in my slides. So Kafka, you have these things that have data, and you want to put it somewhere so to be retrieved from later. You might have a queuing system. So you have producers pushing things onto a topic for consumers to later pull things from that topic and do something with it. And topics can be partitioned and replicated, and the reason for that is for high availability and speed. And you can span the cluster so you could have many machines in a cluster, which makes it highly available, and you can achieve performance. Now, it's actually a database, so it's durable. You have things being saved into, into disks, and so you can achieve something like this. If you have a topic and you have consumers reading from it, they can read at different offsets. That is the cursor of where we want to read from. And so if it's a queue, it is a queue. If you want the beginning of the queue, you would be looking for offset 0, and you would keep going past that and as you are interested. And because it's a database and you can read from it how you like, you can have many consumers consuming from this topic at different offsets at the same time. Now, you can take that topic and you can split it up into different partitions. You can put them on different machines in the cluster, and you can achieve performance this way, highly availability, stuff like that, so that you can have many producers sending messages to different machines that we don't care as a consumer what machine it was on. I just care that I eventually get it, especially if I am a member of a consumer group. And then you also have a topic being split up, and it would look something like this. If you have a topic, you would have the message could go to one of the partitions or another, and you would have different cursors, different offsets for the different partitions. They don't have to be the same. And when you have a cluster and you have many partitions over many servers, you have something like this for your consumer groups. And that's interesting because you can have one group consuming something over here, have another group consuming something over here, and they can read from the topic at different offsets independent of each other. So, quick recap. It's designed for high throughput but low latency data retrieval. It's clustered, scales well to your limits. But that's up to you. And it's designed for pull over push, which is actually a really important thing to think about. You could ask Kafka for things from it and do something with that to your own strategy. You could be polling it. It is poll only. You can't have Kafka notify you about a new message coming in, so you're going to have to go and fetch it on your own. But it's important to remember that it was designed for this. And so at Toyota Connected, since we have a lot of data coming through and we're writing everything in a new project in Elixir, we thought it would be a really good idea to use something like GenStage. And it makes sense to us because they're very similar in ideology. Kafka, it's a database, it's clustered, but what they have a lot in common is you have the same producers and consumers, it's pull-based, you can do it in parallel, where you have many partitions for performance, and you can set up many stages to do something too. And you can make data pipelines from it. So, why? GenStage gives us a behavior for this, so it makes it easy for us to write code to use this. And how it works is consumers place demand on a producer. A GenStage consumer places a demand on a GenStage producer. I should make that distinction. And the demand represents units of work. The consumer just wants X number of messages to do something on. Producers emit events, GenStage producers emit events to eventually satisfy the consumer's demand. And when it can't meet that demand, it's its responsibility to eventually emit those events so that the consumer can do something with it and then ask for more work. And then the cycle repeats once the demand is met, and we just keep going. So in this little chart, we have a producer A, it's feeding data to a producer consumer B, and C is the consumer downstream that ultimately wants the data that usually like this is the last step you want. B might be somebody that's transforming something along the way. Why do we want this? We want to take something like this and turn it into this. So if you've used Flow before, it's very nice. You can give it a set of stages, one or more, and you can map them, flat map them. You can have windows. You can partition them. You can do a lot of parallel stuff, and that's really cool because you might have many CPU cores you want to utilize, and this will help you achieve that. But from the standpoint of a single consumer, so Kafka X is a library that I use for all of the demos I'm going to show you. There are a couple of them. There's Kafka X is written in Elixir. There's also Erlang client library called Broad. And they do a lot of the same stuff. I have an easier time with Kafka X, to be honest with you. Whenever you need to read the code and you need to figure stuff out, it's just easier for me to read Elixir. So to show off the new stuff with Kafka X, they just merged in a new branch or a branch for consumer group stuff, and you have what's called a consumer group supervisor. And you can add it to your supervision tree, and you provide a module that is effectively a callback module, and it's got a gen server behind it. and it can have its own state and everything. And it's going to give you messages into your callback module. And so you'll have to handle that message. And what you're going to get is a message set, which is just a list of KafkaX message structs. And you can do with it whatever you want. So right here, in this simple example, I'm just logging it out. And as soon as I've logged it out, I'm going to commit them, which is going to push the cursor up so that the next time we get messages, we're going to get them after that, so that we don't get duplicates and don't do the same thing twice. So to add GenStage to that, it's a little tricky. So what we're going to do is we're going to create a GenStage producer and a GenStage consumer and add it to our supervision tree. Let's define those. So we have a simple producer. It starts up, and it declares that it's a producer. It's got an empty state of empty list. That will be our buffered events. And we want to, when we handle demand, when the consumer says, hey, give me 5 things, what we'll do is we'll split that off and dispatch some of it right now and save the rest for later, for the next handle demand. And when we satisfy that demand, the consumer will ask again, but they won't ask again until we do satisfy demand. So that's a very important distinction to make. I've spent a lot of time figuring that out. So here's a simple consumer. You tell it to be a consumer, and you implement a handle events callback, and all you'll do, and all we'll do in this example is log it out and sleep for a bit to emulate the work. So here's where things get tricky. The producer's not the one that's creating things. And that's a lot of the examples you'll find of GenStage is the producer is creating something. And so what do you do when you have a third-party thing, some other source providing you things? So what we have to do is we'll have to notify it somehow. We'll have to let it know that there is some new data and it should do something with it. So what we'll do is we'll call this method that we've defined to notify the producer. And when we're done with that, we're going to commit the messages that we have received. So this notify, it's very simple. It's just going to do a GenStage call. So it's going to call itself, and it's going to pass the message set along. So handle call will receive that. And naively, what we'll do is just dispatch them, because we don't know about demand. So we're just going to dispatch them. Alternatively, we could not dispatch them right now, but what we could do is save them for later. So that when we have demand somewhere, some other time, we can just carve them off of our state and emit them at that time. We have problems with this approach. So problem number 1, we are completely disregarding demand. So we have no back pressure mechanism here. We are pushing to the producer instead of letting the producer get things as it needs to satisfy demand. And then we're also committing messages to Kafka before the work's even begun. And if you want to, not do things multiple times on the same message, it's kind of important. Or if you want to get every message, if you commit to a message and then it fails, you're not going to be able to act on that message. And then our producer state essentially mirrors the data in Kafka. So what's the point then? What do I need Kafka for if everything's going to be in my producer? And then the most important thing is that you might crash the VM because you run out of memory, because our producer state is a list of messages. It's growing and it's growing and it's growing and it's growing. That's not good. So there must be another way. So there is. You can sometimes reply and sometimes don't reply. So what we can do is when we have no demand, save it for later, but don't reply. Sorry. Did y'all get that? Okay. So when we said notify, what we're going to do is this is how we handle that. And when we have no demand, we're matching for demand 0. We're not going to emit anything right now because we have no demand. So we'll save it for later. So we'll take that message set and we'll just put it into our state. We'll also remember who's calling. When we have messages coming in that exceed demand, then what we want to do is carve off the messages and emit them now, but we don't want to reply yet because we still have a message set that hasn't completely been dispatched yet. We don't want to act much until the whole set is gone. And then we need to remember the demand, and we need to remember the right amount of demand. So we're going to subtract from the demand the length of what we're dispatching. And last, if we have messages fewer than the demand, we'll just emit them all right now, and then we'll reply. What that will do, once you do reply, it goes back to that callback, and it will commit those messages. Now that that call is no longer blocking, Kafka X can go get some more and let us know that we have more messages and repeat the cycle. And now those messages are en route to our consumer. They have been dispatched. We can trust they'll get there. So we have the other side of it too. We have to do something special with handle demand. So let's see. When we can't emit anything, save the demand, but don't reply. We don't want to reply because we aren't emitting things out. We're not shrinking anything, so let's keep it that way. If we can immediately satisfy demand, we still don't want to reply, and we want to dispatch what we can and update the state to say, hey, we have this much left, and then, but we have no demand, so we'll update that to 0. And in the last case, we eventually can reply. So what we'll do is we'll use that from that we had saved before. This is the other case where we haven't replied yet, but we need to. I think it'd be really cool, though, if we could do something like this. Because all that stuff we just did was kind of complicated. I would like it to be where we could just fetch using the Gen Consumer that we were using. So the new features, you get what's called a Gen Consumer. And I would like it to be that we could fetch the demand directly. So that way it's completely lazy. If the consumer wants this many messages, let's just go get those many messages. Another way would be to stream. Right now in Kafka X, you can do a stream, but you have to tell it not only the topic, but the partition. So you have to watch for partition 0, partition 1, partition 2. If our Gen Consumer has already been assigned a partition because it's a member of a consumer group, then why not just call a stream on that and then take something from that? Maybe that blocks, maybe it doesn't. It's up to you. I think that would be really cool. So I want to say thanks to Toyota Connected for letting us come here and letting us use Elixir to build our Greenfield project. It's really cool. I want to say thanks to Dan for the branch that he got merged in for Kafka X, the work he's done. It was merged only about a week ago, so completely changed my talk. I rewrote everything, like on the plane here. So that was really cool. Any questions?
So I had a question about the use of replying to several calls with a no reply until you did run out of demand. If you do that, does that mean that the original caller will wait until it gets a reply? So the rest of it, so it's just essentially pausing until eventually. Okay.
I did that on purpose because I wanted it to. So the problem was if I don't make it wait, if I don't make it block, then Kafka X or some other library like Broad, what it will do is it will go prefetch. It thinks you are done with it, and it thinks that's the work. So if you don't want that sort of thing, then you should do all the work you want to do in that callback. And when the work is done, then it will answer and it'll return that async commit or sync commit, whatever you want to do. And then Kafka X will go get more. If I don't make it blocking, it will continually getting more data because it's prefetching a lot and it thinks you're done with it, and it's not. We haven't dispatched anything. So I make it block so that I can make it almost like chunk in time. And the timeout you might set a reasonable timeout. The default 5 seconds seems pretty good for probably most things. You can make it infinity if you wanted to, and it's up to you.
Do you have a specific stage in your GenStage pipeline to be able to delegate work to certain consumers based on partition so that you retain ordering across the partitions?
So that's a good question. You can definitely do some partitioning like that in the stage. We could also do it for our case, you could do it getting it into Kafka. So you could have some sort of deal where no matter what, so for us it's vehicles and it's by VIN. And we're getting messages over time, so there's never at the same time. And so what we could make sure is a lot of these messages are going to the same partition so that we can guarantee that they're in order. Because what he's alluding to, or what he's saying is, the messages are guaranteed to be in order on a partition, but not over many partitions. And so that is a legit problem to worry about. I think it depends on how you put it in there and maybe how you group it up together too.
But when it comes back into your consumer group, if it just goes to a consumer,
Right.
If the message comes in through your consumer in your GenStage pipeline, then they just go to whatever consumers there, right? Or do
Right.
you have just one consumer?
This was just one consumer.
I see. Okay.
Simple
So you
demo.
don't have multiple consumers all consuming things.
Not right here.
Cool.
So first, sorry for screwing up your presentation.
How dare you get PRs merged?
And thanks for the publicity. I wasn't the only one that worked on that. There was a lot of work.
I
on
know.
that, so.
Yeah.
Yeah, I mean, that's mostly all I wanted to say. I could talk to anybody who wants to talk about Kafka, and it's pretty complex, and the nuances of writing a client. And also, you kind of hinted at it, but after talking to Matthew, all the hoops that he had to go through to get that to work are kind of ridiculous, and the fetch model is, I think, the way to go. And I've been kind of poking at it for the last few days, so I'm hoping not too long, far away.
Anybody else? Okay.
On the GenStage side of things, if one of your GenStage processes crash while it has a batch of messages, are those messages lost, or do you know if that's retried?
So if that producer went away, we would have something uncaught, and maybe you want to handle that yourself. In my demo, I just wanted to keep it simple. But if you didn't acknowledge those, if you didn't commit those, then they should be still in Kafka. I mean, still the offset, the acknowledged offset should still be back because we never committed those, so it was never sent. So
Okay. Thank you.
does that answer your question?
Yeah.
Okay.
Anyone else? No more questions there? Okay then, well, thank you.